Hello everyone and welcome to this video tutorial. So today I'm going to be talking about asynchronous JavaScript, or in plain English, how you can make JavaScript wait for the result of a function to be available before it goes on to execute some more code. So I'm going to be covering callbacks, promises and async await, which all provide a solution to this problem. So to demonstrate callbacks, first of all, I've created a new variable up here, SomeData, with a value of x. And in the example I'm about to walk you through, this represents some data that you would get from a server. And I've already created a getData function here. So this takes an input value of src, saves that to a variable data, and then returns that as the value of the function. And then down below, I'm calling the getData function, passing in the value of SomeData, so that's the value of x, saving that to a variable called res, and then writing the value of res to the DOM using inner HTML. Now if we take a look at the result of this in the browser, you see that as expected, the value of x is being written to the DOM. But one very important aspect of this example is not realistic. So in practice, trying to get data from an external server, which is what we're trying to simulate here, it's not instantaneous like it is here. It takes a little bit of time. So to make this example more realistic, I'm going to embed the code inside of the getData function inside of a set timeout. So there's going to be a delay on getting the data, which is what would happen if you're getting the data from an external source. And I'll give it a delay of 1 second. Okay, so if we take a look at the result of this now, in the browser, you see that we're printing undefined to the DOM. So the reason this occurs is that the return value of the getData function, it's now not available for a second, but JavaScript doesn't wait for processes it knows will take some time, like set timeout. Instead, it goes ahead and executes the rest of your script. So it writes the value of res to the DOM, which is undefined, and only after that is the return value of getData going to be assigned to res, so it's going to be too late. So let's see how we can solve this problem using a callback function. Okay, so the solution of callback functions is to call another function after the process inside set timeout is fully complete, and that next function you call will contain the code that you want to wait for the result. So in this case, the writing of res to the body of the document. So I'm going to add a second parameter to the getData function. I'll call that callback. So this is going to be a function. You can call it whatever you want. Next function, for example, usually it's called callback, but I'm not going to define this function here inside the definition of the getData function. I'm going to define it when I call getData. So I pass in the callback function as an argument. Now inside the second argument function here, which is callback, I'm going to add the writing of res to the DOM. And now within the getData function, I want to call callback when data is available. So instead of returning data here, I'm going to call the callback function, passing in the value of data. So now because I'm doing this, the value of data is now available in the callback function. So I'll call that res here, and then I delete the saving of the return value of getData because it no longer has a return value. The value of data is now being passed to the callback function. Now if we take a look in the browser and I refresh, you see that the value of x is being printed to the DOM after 1 second. So the callback function that's writing this x to the DOM here, it's only being called inside the getData function when the value of x is available. So this is a realistic but still simplified scenario. So next what we'll take a look at is an example of a real API call that uses this logic. So this API call here, this uses Ajax. So the request is made and then the response from the server is waited upon by attaching an event listener to the request object, and then the result is processed, and when it's ready, callback is called, passing in the value of res, which is the data payload. So with this function, callback is a function to be defined as the first argument when you call getData. So here we are calling getData and defining the callback function. because we passed the data payload into it. We have that available to us as a parameter, and inside here the contents of the data payload is written to the DOM. Now we can take a look at the output in the browser because this is a live example to a test API. Now unfortunately, if you're using live server and you run this code, you will get a cause error, so you need to make sure that you're running the document locally, and then you will see the result, something like this. So this time the getData function waits for data to come back from the server, and only then is the callback function fired, which writes this data to the DOM. So this is the way that you can handle the result of an AJAX request using callbacks. Now, despite the fact that we have more modern methods, callbacks are still used very commonly in modern JavaScript. So you may have defined callback functions in the past without even knowing it. For example, an event listener, you define in the second position a callback function which fires when the event occurs. Set timeout accepts a callback function in the first position which fires after a time you specify as a second argument, and set interval works in the same way apart from the fact that it's repeatedly calling the callback function. Now, not everyone likes using callback functions for handling asynchronous code in JavaScript, and one of the reasons is what some people refer to as callback hell. So when people refer to callback hell, they're referring to this kind of situation where you have a callback function inside which another callback function is defined, inside which another one is defined, and so on. So this leads to this kind of messy nesting situation where it's quite hard to see what's going on. So for example, the second argument of the first set timeout is all the way down here, and it therefore leads to code that is quite hard to maintain. So callback hell gets a lot of attention, but there is another equally important problem with callbacks. And the issue is that with callbacks, the sequencing of tasks is not very flexible. So let's say in addition to the first bit of data, I want to get some more data. So for example, I'm making a separate API call, and then I want to write the contents of some data and more data to the DOM after both are complete. So the straightforward way of doing this with callbacks is to make another getData request in the callback function in getData, and then in the callback function for the next getData, then I write the results to the DOM. So I'll do that now. I call getData again, passing in more data. In the second position, the callback function, where I have available to me the data, more data, and then I want to write the content to the DOM. Now, in order to be able to write both data payloads to the DOM, I'm going to define a new array before I even call getData, and I'm going to push the results into that. So first of all, the result of the first request, and then the result of the second request, and then I'm going to be writing the array with those two values to the DOM. So this code works, but it's taking an entire 2 seconds to be able to write the values to the DOM. Now this is inefficient because each request only takes 1 second. So if the result of Y doesn't depend upon getting the result of X back first, then we're waiting a second longer than we should be. So the callback solution is very good when you want to wait for a process to fully complete before starting the next one. So you want to process things sequentially. It's not so good when you need flexible handling of asynchronous code. So ideally, you'd want both bits of data to be requested immediately, and then after just 1 second, when both are available, you'd want them both to be written to the DOM. And it's exactly that kind of flexible result handling that you get with promises, as well as a solution to the nesting problem of callback hell. So the getData function here is the same as in the previous script before we solved the set timeout problem with a callback function. So if we take a look in the browser, we're writing undefined to the DOM here. So this time I'm going to solve the problem again, but this time using the more modern feature of a promise. So to solve this with a promise, the first thing you do is to create a new promise. So the way that you do that is by calling the native promise object using the new operator for it. So that will create a new instance of a promise object, and then inside the promise parentheses you define a function which is going to contain whatever process it is you want to occur within this promise. So I'm going to nest the set timeout in this new promise that I've created. Now, what a promise makes available to you as parameters inside the function that you define within it are resolve and reject. Now, you could call these whatever you want, but these are the respective roles of the two parameters. The resolve parameter is always going to be in the first position, reject in the second position. Now, when you reference or call either one of these two parameters inside the function, the promise ends either successfully or unsuccessfully. So the way that these two parameters work is a little bit like the return keyword in a regular function, in that once you reference or call either one of them, the function stops processing anything else and a value is returned for the promise. So what I'm going to do here, instead of using the return keyword, is call resolve, passing in the data. So the value that you pass into resolve is going to be what the promise returns if it is successful. Now, to make this example more complete, we'll also create the possibility of reject being called. So we'll say if data is equal to a falsy value, then the result of the promise is that it's going to be rejected, and you can pass in some information here about why. So in this instance, there's no data. So we've set up the promise here to reject or resolve after 1 second, and after that second, it's going to return the result of the promise. So I want to make that return value the return value of the getData function. So now when the getData function is called, it's going to return a promise. So we're calling the getData function down here. I'll pass in some data as the value of src, and let's take a look at that return value of a promise in the console. So taking a look at the result here, you see what we get back is a promise with a status of pending. Now, the reason we get this result is because this console log is not waiting for the status of the promise to change because we called resolve or reject. It's just console logging the promise object right away. So to handle this situation, promises have their own special syntax that allows you to wait for the status of a promise to change from pending to fulfilled or rejected. So the way that you can access the result of a promise that resolves successfully is by using the then method on the result. Now inside the then method, you pass in a function that is going to fire if the promise resolves successfully, and you have available to you there the result. So I'll just log that to the console. So let's take a look at that. So if I refresh here, I have to wait a second, and then I get the value back that I passed into resolve within the promise. Now, to deal with an unsuccessful promise, what you need to do is add a catch statement here. So this is going to fire if reject is called within the promise, and what you have available to you in the function that you pass in is whatever value you passed into reject. So I'll log the value of the error to the console, and to make the promise fail, I'm not going to pass in any data to it. Now if I refresh, after a second, I get back the no data message. So when working with promises, it's the then statement that fires if the promise successfully resolves, and it's the catch statement that fires if there's an error. Now let's take a look at handling multiple promises, because with callbacks, we had this problem that we could only execute one asynchronous process at a time. With promises, we have more flexibility. Now, if you want to handle multiple promises, it's a good idea to store them in an array. So I'll create an array here, and because this promise is actually inside a function, I'm going to be calling the function inside the array each time here. So a promise runs as soon as it's encountered by the script. So as soon as this array is defined, it's going to start running the promises. The only difference between the two of them is in the first one, getting some data, and in the second one, I'm getting more data. And now, instead of calling the getData function directly, so I'm going to use the promise object here, the same one you use for creating new promises, because this has methods on it that allow you to handle multiple promises, so objects of its type. So the one I'm going to use is all, and I need to pass in the array of promises. Now, we don't actually need to change anything about the result handling here, because promise.all is going to take care of waiting for the result of both of these promises and then concatenating the results in an array. So let's take a look at the result in the browser now. If I refresh, you see I'm getting back an array, and this is coming back after 1 second. So because I called getData twice inside the promises array, 2 new promises were created and start processing immediately, and the promise.all method allows me to handle the result of both together. Now, the great thing about the promise object is it has other methods you can use to handle the promises. So you can wait until all are settled, in which case you're going to get an array back also containing the status of each of the promises, so they both fulfilled. But if I call one of those getData functions without a value, you'll see that we get back this rejected status. There's also a promise.any method that's going to return the value of the first promise to successfully complete. So in this case, it's going to be the value of more data, which is y. So with promises, you have lots of flexibility in terms of how you handle multiple asynchronous processes that you don't have with callbacks. Now, the final thing I want to show you is async await. So async await isn't a separate method from promises, it's a syntax that you can use to handle the results of promises in a way that is more natural looking than using the then and the catch methods. So it's a good idea not to skip ahead to async await before you understand promises, because under the hood, async await works with promises. So as you can see here, the script is starting in the same way. The difference this time is how we're going to be handling it. So we're going to be using async await syntax. Now, the first thing I'm going to do is to create a function, because you can't use async await outside of a function. So to create an async function, you use the keyword async before it, and then I'll call this function handler. And then inside, this enables the use of the keyword await. So the way that the await keyword works is when you use it before a promise. So getData returns a promise. So because I use the keyword await before it, nothing else in the function is going to process until this result is available. Now, the return value of the promise, it's now available as the return value of the function, just like it would be if you were writing synchronous code. And I'll log that result to the console. And of course, I need to remember to call the handler function. Okay, so let's take a look at that in the browser. If I refresh, after 1 second, I get the return value of the promise. It resolves successfully, so I'm getting the value that I passed into resolve. Okay, so that's how you handle a single promise. Let's imagine now you want to handle more than one. So you want to call getData twice, getting some data first and then more data. So it's quite straightforward. I'll call this res2, use the await keyword before getData again, passing in more data, and then I'll log that result to the console. So this is going to replicate callback behavior, where we wait for the result of the first promise and then log it to the console, and only then is getData called, starting another promise, and then we're logging the result of that to the console. So let's take a look at that in the console. So after 1 second we get X, after another second we get Y. Now, if you want to use the inbuilt promise object for more flexible result handling, you can also do that with async await. So I'll do that exactly like I did last time. I'll create a new array in which I'm calling the getData function twice. That's going to create 2 promises. And then I'm going to call a method on the promise object. So I'll use promise all again, passing in the array. Now this is returning a promise, so I want to await the result of that, and I'll save the result of it inside a variable called res, and then I'll log the result of that to the console. So it's working in exactly the same way as it was before with promises, but this time we're handling the result with async await. So you can of course also use the other methods available on the promise object here. such as any or all settled. Now finally, let's take a look at how you do error handling in async await. So the way that you do this is quite simple. You create a try statement where you nest what it is you're trying to do, and then you create a catch statement to catch any error that occurs when you're executing the try statement. So in the catch statement, I'll just log the error here in case there is one. And to create an error, I'll just delete the data from the getData function calls. And then if I refresh, so you see that I get the no data message, which is what we were passing into the promise if reject is called. So that's what happens when there's an error. So the really nice thing about async await is it allows you to handle promises like this using synchronous looking code rather than the then and catch statements. But it's important to remember that under the hood, async await is dealing with promise objects. So that is it for this tutorial. I hope you understand how to deal with asynchronous code using callbacks, promises, and async await a little bit better now. If you did find this tutorial useful, please consider hitting the like button down below to help others find this video. And if you'd like to see more content like this in the future, don't forget you can subscribe to the channel.